So welcome to this session. As promised in the previous demonstration of the Taylor's series of a function of two variables, we are going to do an example to illustrate how to apply it. So example. So the example is expand the function f of xy given by e raised power x sine of y in powers of x and y, x equals to 0 and y equals to 0, as far as terms of third degree. So that's the problem. So remember, this is an example on Taylor's theorem. For a function of two variables, x and y. So what we do, we have to write the correct formula for this problem. So clearly they want us to go or to write our formula up to the third derivative. So that's when we get the third degree. So Taylor's theorem about a point AB is given by f of xy equals to f of a comma b plus h partial x plus k partial y, and then f at AB plus 1/2 factorial into h partial x plus k partial y squared, and then times f at a b plus 1/3 factorial into h partial x plus k partial y power 3 f at a b plus other terms, because actually they want us to go up to third order, then we just stop here, but show that there are more other terms after that. So in our case, A, B is the point 0, 0. So therefore, the Taylor's theorem or the Taylor's formula will be f of x comma y equals to f at 0, 0 plus h partial x plus k partial y, f at 0, 0 plus 1/2 factorial into h partial x plus k partial y power 2 f at 0 plus h partial x plus k partial y f at 0, 0 and then power 3 and then 1/3 factorial plus other terms. So call this one formula 1. So therefore, the thing will be now to find these derivatives. Remember, we need to have partial f, partial x, and then partial f, partial x. Remember, the f is given by e raised power x sine of y. So partial f partial x will be given by e raised power x sine y, which means that partial f partial x is at the point 0, 0 is e raised power 0 sine of 0, which is just 0. And then partial f partial y will be negative, this positive, e raised power x cos of y, which means that partial f partial y at 0, 0 is given by e raised power 0 cos of 0, and the answer is 1. So next, partial squared f partial x squared. Now we differentiate this first derivative with respect to x. So we'll have e raised power x sine of y, which tells us that partial squared f partial x squared at 0, 0 will just be e raised power 0 sine of 0, which is 0. And then partial squared f partial x partial y. So then it's the same as differentiating this one with respect to y, or differentiating this one with respect to x. So with respect to x or y for these two respectively, we'll have e raised power x and then cosine of y, this one here, which means that partial squared f partial x partial y at 0, 0 is e raised power 0 cos of 0, which is 1. And then partial squared f partial y squared. So differentiate this with respect to y, we get minus e raised power x sine of y. So it tells us that partial squared f partial y squared is at 0, 0 is negative e raised power 0 sine of 0. We get 0. So those are all the second order derivatives. Now let's go to the third order derivatives. So partial cubed f partial x cubed. So you simply differentiate this partial squared f partial x squared with respect to x. So we get e raised power x sine of y, which tells us that the value of this partial derivative at the point 0, 0 will be e raised power 0 sine 0, which is just 0. Next, we find partial cubed f partial x squared and then partial y. So simply once we have the second partial derivative with respect to x twice, then differentiate with respect to y, and this will give us e raised power x cos of y. So it tells us that third partial derivative of f partial x squared partial y at the point 0, 0 will be e raised power 0 cos of 0, which is 1. And then next one, partial cubed f partial y cubed will be, now this one you differentiate with respect to y, so you get negative e raised power x cos of y, we tells us that partial cubed f partial y cubed at 0, 0 is given by negative e raised to power 0 cos of 0 is negative 1. And then lastly, partial cubed f partial x, now partial x squared, y squared. That means that this second derivative of f with respect to y, you differentiate is now with respect to x. So you get negative e raised to power x. And then this will give us sine of y. So it tells us that partial cube f partial x partial y squared at 0, 0 is negative e raised to power 0 sine 0, which is 0. So therefore now, if you call all these values, call it 2. All these values, call them 2. Then using 2 in 1, we have, so f of x comma y. Remember, the formula is f at 0, 0. So f at 0, 0, we have the answer as, so the function x comma y is e raised to power x sine y. So it tells us that f at 0, 0 will be e raised to power 0 sine of 0, which is 0. So this part will be 0. So we'll have 0 plus, I remember x, a equals to 0 implies that x minus a, which is h, will be x equals to h. And similarly, y equals to k for the case when b equals to 0. So therefore, this formula 1, where there's h, you replace x, where there's k, you replace y. So you'll have x times, and then the first partial derivative with respect to x, our answer here was 0. Plus our second partial derivative with respect to the first derivative with respect to y, the answer was 1. And then k the same as y. Plus, now this part, I remember this one from what we trained first. So or maybe just write this one in expanded form. Just pause this one first. So say we have f of x, y equals to f of 0, 0 plus x partial x, and then plus y partial f partial y, and then plus 1 over 2 factorial x partial f partial x plus y partial f, partial y, and then plus. So I just want to write the expanded form of this one so that we can see how it replaces in the derivatives. 1 over 3 factorial into x partial f partial x plus y partial f partial y over 3 actually I can just write this f outside so that when I start now opening the brackets, it will be fast, it will be easier for us to understand what's happening. So just write f of 0, 0, f of 0, 0, f of 0, 0, plus other terms. So expansion of this one is what we have, f of x comma y equals to f of 0, 0, plus this one will just be x partial f partial x, but at 0, 0, plus y partial f partial y at 0, 0, plus now this squaring, just the same as a plus b squared. We know it will be given by a squared, so x squared partial squared partial x squared, then f at 0, 0, plus twice ab. So we'll have 2 xy partial squared f 0, 0 over partial x partial y, and then plus b squared. So plus, so when you square this one, you have y power 2 partial squared f at 0, 0 over partial y squared. So this is expansion of this term. And then remember, everything is multiplied by 1 over 2 factorial. So it's like I have over 2 factorial is just 2, over 2, and then everything here over 2. Plus 1 over 3 factorial, which this, remember this, like I have power 3 here. So a plus b power 3, you know, it is a cubed. So I'll have x power 3 partial cubed partial x cubed, and then I bring in the f at 0, 0, plus 3a squared b. So I'll have 3 a squared. When you square this one, I get x squared. Then this I get y, and then partial power 3. So partial x squared partial y f at 0, 0, and then plus 3. So remember, this is the same as a cubed plus 3a squared b plus 3ab squared plus b power 3. So next one will be 3ab squared. And remember, this is our a, this is our b. So I'll have plus 3 x, and then squaring this one, I have y squared partial cubed partial x partial y squared f at 0, 0, and then plus b cubed. So this is y power 3 partial cubed f at 0, 0 over partial power 3, and then plus other several terms. So now with this one, it's now easier to say now for those replacements from the values we've gotten. So from our working up there, where this f of 0, 0 will replace by 0, where this first partial derivative will replace by 0, where this partial derivative with respect to y, first one, the answer is 1. So this has 1. Second partial derivative with respect to x, our answer is 0. So this part is 0. Second partial derivative, partial x, partial y. The answer is 1. So this part is 1. Second partial derivative with respect to y. The answer is 0. And then third partial with respect to x. The answer is 0. So this part is 0. Third partial derivative of x squared, then y, is given by 1. And then third partial of x, y squared is given by 0 from our calculation. And then this other one is given by -1. So therefore now our function reduces to f of x comma y. So this will be 0. So 0 times this, yes. So this part, everything here goes to 0. Also here goes to 0. Everything 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 here goes to 0. So then our function will be, so this will be 1 times this, I get y. And then 1 times this one, I get, so 2 by 2 cancels out, so plus xy. And then this is 0. So I have 1 over 3 factorial, which is 6. So 1 over 6 times 3, I get a half, and then x squared y. 1 over 6 times -1, I get minus y cubed, then plus other values. So in these values that we're obtaining here, we had only -1 at third partial derivative of f with respect to y. So therefore the function will be f of x y equals to y plus xy plus a half x squared y minus y power. So this, remember this y power 3, then you are being multiplied by 1 over 3 factorial. So we have 1 over 6 there. Also, this bracket is being multiplied by 1 over 3 factorial. So this is the desired solution to that given problem. Thank you.